The National Electrical Code, or NEC, provides guidelines for transformer installations, particularly concerning their proximity to buildings. While the NEC doesn't explicitly detail clearances between windows in masonry walls and transformer enclosures, Article 450 offers general guidance for installing transformers adjacent to buildings. Specifically, Section 450.12 states that transformers should be located at least 6 feet from any building or structure unless a fence or barrier provides separation. Furthermore, Section 450.16 emphasizes the importance of adequate working space around transformers for maintenance and repair. This section mandates maintaining clearances of at least 3 feet on all sides of readily accessible portions of transformer enclosures. Even though the NEC doesn't specifically address windows, it's crucial to ensure any openings in the masonry wall maintain adequate safety clearances from the transformer enclosure. To minimize potential electrical hazards, adherence to industry best practices is paramount. Concerning horizontal clearance, a minimum of 6 feet should be maintained between the edge of the window opening and the nearest exposed transformer surface. Regarding vertical clearance, the bottom of the window opening should be positioned at least 3 feet above the top of the transformer enclosure. In addition to these clearances, implementing additional safety measures is advisable. Firstly, consider installing barriers or screens over the window opening to prevent accidental contact with the transformer enclosure. Secondly, post warning signs to alert occupants of the potential electrical hazard. Thirdly, consult with a qualified electrician to ensure compliance with all applicable codes and standards. It's important to note that these recommended clearances may vary depending on local codes and regulations. Always consult with local authorities to determine the specific requirements in your area. In summary, while the NEC provides general guidelines, specific window clearances require a combination of code interpretation, industry best practices, and local regulations. Prioritizing safety and consulting with qualified professionals is crucial when installing transformers near buildings with windows. The primary focus is on preventing accidental contact with the transformer and ensuring sufficient working space for maintenance. Understanding these guidelines and recommendations ensures a safe and compliant electrical installation. The 6-foot rule from buildings or structures refers to the distance between the transformer enclosure and the building itself. If a fence or barrier is used, it must effectively prevent unauthorized access and physical contact with the transformer. The 3-foot clearance for working space applies to all sides of the transformer enclosure that are readily accessible. This space is necessary for electricians and other qualified personnel to safely perform maintenance, inspections, and repairs. When determining the horizontal clearance for windows, measure from the edge of the window opening to the nearest point on the transformer enclosure. This measurement ensures that there is sufficient distance to prevent accidental contact or arc flash hazards. The vertical clearance is measured from the top of the transformer enclosure to the bottom of the window opening. This clearance prevents objects from being dropped into the transformer enclosure and ensures adequate ventilation. Barriers or screens installed over the window opening should be non-conductive and strong enough to withstand accidental impacts. They should also be designed to allow for adequate ventilation and visibility. Warning signs should be prominently displayed near the window to alert occupants of the potential electrical hazard. The signs should be clearly visible and use appropriate symbols and language. Consulting with a qualified electrician ensures that the installation complies with all applicable codes and standards, including the NEC local amendments and utility requirements. The electrician can assess the specific site conditions and recommend appropriate clearances and safety measures. Local authorities, such as the building department or electrical inspector, can provide information on local codes and regulations. They may have specific requirements for transformer installations near buildings with windows. Remember that these are general guidelines and specific requirements may vary depending on the specific installation and local conditions. Always consult with qualified professionals and local authorities to ensure a safe and compliant installation. Now let's elaborate on some specific aspects of transformer installations and clearances. Firstly, consider the type of transformer. Pad-mounted transformers are typically installed outdoors and are designed to be tamper-resistant. However, they still pose a potential electrical hazard, especially if located near windows or other accessible areas. Secondly, the voltage of the transformer is a critical factor. Higher voltage transformers require greater clearances to prevent arc flash hazard. Consult the NEC and local codes for specific clearance requirements based on the transformer voltage. Thirdly, the environment surrounding the transformer should be considered. If the area is prone to flooding or other hazards, additional precautions may be necessary. Fourthly, the accessibility of the transformer is another important factor. If the transformer is located in an area that is easily accessible to the public, additional security measures may be required. Consider installing a fence or barrier around the transformer to prevent unauthorized access. Now let's dive deeper into the NEC requirements for transformer installations. Article 450 of the NEC covers the installation of all types of transformers. Section 450.11 addresses guarding transformers. It states that transformers must be protected from physical damage and must be guarded against unauthorized access. Section 450.21 through 450.28 covers the requirements for transformer overcurrent protection. These sections specify the type and size of overcurrent protection devices required for different types of transformers. Section 450.41 through 450.47 covers the requirements for transformer grounding. These sections specify the grounding requirements for different types of transformers and enclosures. In addition to the NEC requirements, local codes and regulations may have additional requirements for transformer installations. These requirements may vary depending on the specific location and type of installation. Always consult with local authorities to determine the specific requirements in your area. Let's discuss the potential hazards associated with transformers. Transformers can pose several potential hazards, including electrical shock, arc flash, and fire. Electrical shock can occur if a person comes into contact with energized parts of the transformer. Arc flash is a dangerous electrical explosion that can occur when a fault occurs in the transformer. Fire can occur if the transformer overheats or if there is a fault in the transformer wiring. To prevent these hazards, it is essential to follow all applicable codes and standards and to implement appropriate safety measures. These measures may include installing barriers or screens, posting warning signs, and providing adequate working space around the transformer. It is also essential to ensure that the transformer is properly maintained and inspected regularly. Regular maintenance and inspection can help to identify potential problems before they become hazards. Now let's talk about the importance of consulting with qualified professionals. Installing and maintaining transformers requires specialized knowledge and skills. It is essential to consult with qualified professionals such as electricians and engineers to ensure that the installation is safe and compliant. Qualified professionals can assess the specific site conditions, recommend appropriate clearances and safety measures, and ensure that the installation complies with all applicable codes and standards. They can also provide guidance on transformer maintenance and inspection. In conclusion, transformer installations require careful planning and attention to detail. By following all applicable codes and standards, implementing appropriate safety measures, and consulting with qualified professionals, you can ensure a safe and compliant installation. Remember that safety is always the top priority when working with electricity. Always take the necessary precautions to protect yourself and others from electrical hazards. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with qualified professionals and local authorities to ensure compliance with all applicable codes and standards. Now, let's delve into some specific scenarios and considerations related to transformer clearances. Scenario 1. A transformer is located near a window that is frequently opened. In this case, it is essential to ensure that the window cannot be opened in a way that would allow a person to come into contact with the transformer. Consider installing a barrier or screen that prevents the window from being opened beyond a certain point. Scenario 2: a transformer is located near a window that is used for ventilation. In this case, it is essential to ensure that the window does not obstruct the transformer's ventilation openings. Transformers require adequate ventilation to prevent overheating. Ensure that the window is positioned in a way that does not block the airflow around the transformer. Scenario 3: a transformer is located near a window that is used for emergency egress. In this case, it is essential to ensure that the transformer does not obstruct the egress path. The transformer should be located in a way that allows people to safely exit the building in an emergency. Scenario 4: a transformer is located near a window that is used for maintenance access. In this case, it is essential to ensure that the transformer does not obstruct the access path. The transformer should be located in a way that allows maintenance personnel to safely access the window for cleaning and repairs. These scenarios highlight the importance of considering the specific use of the window when determining transformer clearances. Always prioritize safety and ensure that the transformer installation does not create any hazards. Now, let's discuss some additional safety measures that can be implemented to protect against electrical hazards. Firstly, consider installing ground fault circuit interrupters, or GFCIs, on circuits that supply power to the transformer. GFCIs can detect ground faults and quickly disconnect power to prevent electrical shock. Secondly, ensure that all transformer enclosures are properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and arc flash. Thirdly, use insulated tools and equipment when working on or near transformers. Insulated tools and equipment can help to prevent electrical shock. Fourthly, wear appropriate personal protective equipment, or PPE, when working on or near transformers. PPE may include safety glasses, gloves, and flame-resistant clothing. Fifthly, never work on energized transformers unless you are qualified and authorized to do so. De-energize the transformer before performing any maintenance or repairs. Sixthly, follow lockout/tagout procedures when de-energizing transformers. Lockout/tagout procedures ensure that the transformer remains de-energized while work is being performed. These additional safety measures can help to reduce the risk of electrical hazards when working with transformers. Always prioritize safety and follow all applicable codes and standards. Now, let's talk about the importance of regular transformer maintenance and inspection. Regular maintenance and inspection can help to identify potential problems before they become hazards. Maintenance and inspection should be performed by qualified personnel. Maintenance tasks may include cleaning the transformer enclosure, tightening connections, and inspecting for signs of damage. Inspection tasks may include checking the oil level, testing the insulation resistance, and inspecting for signs of overheating. The frequency of maintenance and inspection will depend on the type of transformer, the environment in which it is located, and the operating conditions. Consult with the transformer manufacturer for recommended maintenance and inspection schedules. By performing regular maintenance and inspection, you can help to ensure that your transformers are operating safely and reliably. This will also help to extend the life of your transformers and reduce the risk of costly repairs. Now, let's address some common misconceptions about transformer clearances. Misconception 1: the NEC provides specific clearance requirements for all types of transformer installations. Fact: the NEC provides general guidelines for transformer installations, but specific clearance requirements may vary depending on local codes and regulations. Misconception 2: if a transformer is located behind a fence or barrier, it does not need to meet the minimum clearance requirements. Fact: while a fence or barrier can provide some protection, it does not necessarily eliminate the need for minimum clearances. The fence or barrier must be designed and installed to effectively prevent unauthorized access and physical contact with the transformer. Misconception 3: only qualified electricians need to be concerned about transformer clearances. Fact: everyone who works near transformers should be aware of the potential hazards and the importance of maintaining safe clearances. Misconception 4: transformer clearances are only important for outdoor installations. Fact transformer clearances are important for both indoor and outdoor installations. The potential hazards associated with transformers are the same regardless of the location. By understanding these common misconceptions, you can help to ensure that transformer installations are safe and compliant. Always consult with qualified professionals and local authorities to determine the specific requirements for your installation. Now, let's discuss the role of technology in improving transformer safety. Technology is playing an increasingly important role in improving transformer safety. For example, smart transformers can monitor their own condition and provide alerts when potential problems are detected. These alerts can help to prevent failures and reduce the risk of electrical hazards. Another example is the use of drones to inspect transformers. Drones can be used to inspect transformers from a safe distance, which reduces the risk of electrical shock and arc flash. Technology can also be used to improve the design of transformers. For example, new transformer designs are more efficient and generate less heat. This reduces the risk of overheating and fire. As technology continues to evolve, it will play an even greater role in improving transformer safety. By embracing new technologies, we can make transformer installations safer and more reliable. Now, let's address some common questions about transformer clearances. Question 1. What is the minimum clearance required between a transformer and a building? Answer. The NEC requires a minimum clearance of 6 feet between a transformer and a building, unless a fence or barrier provides separation. Question 2. What is the minimum clearance required around a transformer for working space? Answer. The NEC requires a minimum clearance of 3 feet on all sides of readily accessible portions of transformer enclosures. Question 3. How do I determine the specific clearance requirements for my transformer installation? Answer. Consult with local authorities and qualified professionals to determine the specific clearance requirements for your installation. Question 4. What are some additional safety measures that I can implement to protect against electrical hazards? Answer. Some additional safety measures include installing GFCIs, grounding transformer enclosures, using insulated tools and equipment, wearing appropriate PPE, and following lockout/tagout procedures. Question 5. How often should I perform maintenance and inspection on my transformers? Answer. The frequency of maintenance and inspection will depend on the type of transformer, the environment in which it is located, and the operating conditions. Consult with the transformer manufacturer for recommended maintenance and inspection schedules. By understanding the answers to these common questions, you can help to ensure that your transformer installations are safe and compliant. Always prioritize safety and follow all applicable codes and standards. Finally, let's reiterate the importance of safety when working with transformers. Transformers are powerful electrical devices that can pose significant hazards if not handled properly. Always prioritize safety and follow all applicable codes and standards. Consult with qualified professionals and local authorities to ensure that your transformer installations are safe and compliant. Remember that electrical safety is everyone's responsibility. By working together, we can create a safer environment for ourselves and others.